Hey, good afternoon. It's Wednesday, March 4th, 2026. And we're here in Altadena working on the house. We have everything ready for inspection. The inspector postponed his visit. So I think we got everything ready here, and we're going to start on the outside. Show you guys a few things. Give you a couple of little code rules as well. They should be helpful to ambitious plumbers, electricians, and HVAC guys. Okay, so here we have a water service. The main line comes from here, going back to the front yard. So I brought the pipe in, and it kind of comes here, and it's going to make a 90-degree turn there, and then we have a tee off here. Now, the reason why we did all of that was because the fire sprinkler company had come in after we had run our water line, and that hole right there that you see in the wall was the original inlet location to the fire sprinkler system that's going to go in the house. I had set everything up to where we would be able to actually bring the pipes back this way, or catch the pipe as it comes through here, put a T on it and bring it up and into here. But as it turns out, he shot it to the far side of the inlet, and I ended up having to create an extension, because I would say from here back maybe about 7 feet, it's all copper. So instead of having to kind of dig up all of this stuff, we kind of did a little shortcut move where I made a 90-degree turn here, teed it, and then we continued straight. Now, the reason why we didn't go straight across was because the foundation wall was kind of ballooning out over here, and we had asked the people who did the foundation work to give us this little zone where, you know, it could balloon out, but not too much. And I don't know if you can see over here, you can see signs where we kind of dug out the concrete. So that was kind of, you know, it just created a little problems for us, but we worked it out. And in case some of you guys may have noticed, there's some red tape and a blue wire here. And most people don't know what that's for, but whenever you run plastic piping on a water service, no matter whether you have sections of it that are copper or what, you're supposed to have a tracer line where a line locating company or a plumbing company that has line locating equipment can actually follow the path of the pipe using a device that picks up a radio signal that they have run through this wire, and then they have like a wand that'll tell it that it's on top of the wire. So that's what the blue wire is for. And so we ran copper, because copper is nice and solid. We ran that for all of our inlets going in, but as far as running all of this in copper would be super duper expensive, and the customer was given the option to pay us more money to have it all copper, or to just, you know, we'll give it to you at our basic price for running it mostly in PVC. So, and another thing, this is 1-inch PVC pipe, and I don't know if you notice the coupler right there. If you look here, that's an integrated coupling. You see how kind of it balloons out and overlaps the other pipe as it inserts? Over here we have like a straight cut piece of pipe, and I actually created a coupler. And the reason why this coupler is extra large is because if I did like a 1-inch coupling where I have a 1-inch threaded male adapter to and then a 1-inch slip on that side, then it's been kind of like a historical problem for me, in that I've had it to where a coupling would explode or crack on me within a year or two after the install. So I figured if I use, say, 1.25" coupling, and then I insert a reducer, that reducing just adds more thickness to the pipe. So we have we got a 1" to a 1 by 1.25" adapter, and you can kind of see it kind of sticking out a little bit from the actual coupling itself. And then on the other side I did the same thing. We got a 1.25" by 1" threaded bushing. So these are bushings, and so the thickness of the bushing combined with the thickness of the actual coupling gives me a little extra strength. And ever since I adopted that as a philosophy of doing plumbing work, I have never had a callback where the threaded end ended up splitting and creating a leak for me to have to come and repair. Okay, so anyway, just gonna walk through here and show you guys how we ran this 1" pipe. We had to run it 1" because that's what the blueprints call for based on the fire code plan. And then we did a transition back to 1", and there you see I did the same thing over here. We got the 1.25" by 1" reducer, 1.25" by 1" on the other side. Transition to copper, and it brings it up. And here we are in the garage. You can see we got the sprinkler system installed here. We got our junction box for the garage door opener and our 2 junction boxes for our light fixtures here. And then we gave them plugs, 1 circuit on the system for the plugs here, and then we have a separate GFCI for the exterior plugs as well. And believe it or not, this is chained to the GFCI plugs that are surrounding the perimeter of the house, the rear side of the house. Okay. Now over here, I ran my refrigerant lines for my condensing unit, but in this particular case, it's going to be what they call an inverter. An inverter is different from a condensing unit because a condensing unit is specifically for air conditioning devices. An inverter, it's going to sit outside the house the same way a condensing unit does, but it's designed for a heat pump. So you can get heating service and cooling service in that particular mode. So I got my thermostat control wires, my low voltage, which will turn the unit on and off. And then we got the high voltage power here. The system that we're putting in, it was rated, I think, at 20 amps, but we decided to use 10 amp gauge wire. And then we have our service plug here. We got our hookups for the water heater here, and it's going to be a heat pump style water heater. And we got the power plug here. I'm going to create an outlet here, and we'll have a pigtail where if I need to service the equipment here, I just can unplug the device from the unit. And then we have another service plug for the technician working on the water heater here. Okay, and then we got hose bibs, and maybe I'll show you guys that little dipsy doodle. There's if you guys rewind the video at the beginning where we were looking at the valve assembly, you'll see a little 3/4 inch valve over there by the main valves that supply the house as well as the fire sprinkler. Basically, I set up all of the hose bibs around the perimeter of the house. There's one there, there's one here in the front. All of them around the perimeter of the house are going to be controlled by that one valve. So let's say, for example, they got to do some plumbing work in the house and they have to turn all of the water off in the house. Well, we'll still be able to supply water, you know, say fill up a bucket to flush toilets if there's some major reason why we have to turn the water off in the house. So I'm trying to be very thoughtful and considerate about things here, and didn't take me much more time to add that, but This is just how we do it. And so I think you guys saw the last video where we were doing all of the wiring. So we got all the wiring in now. So we got our recessed lights in, we got our registers for the air conditioning system here, and we even sealed up the openings because we don't want to get paint or plaster inside where the drivers for the recessed lights are going to go in. And we have like a double shear wall here, so all of this wiring had to be kind of set in place. They'll end up taking these pieces off the day of the inspection. We had an inspection scheduled for today, but the inspector didn't show up. So we ran all our duct work here, and there's our air conditioning unit up there, or HVAC system there. And I don't know if you guys noticed, but all of my condensation lines are wrapped with insulation. And the reason why I do that is because we're close to the ocean, but we're here in the mountains of Altadena, and it's been super humid out here. I don't know if it's a change of weather patterns or whatever, but that cold water, even on a PVC pipe, can create sweat, and it can accumulate to a point where you build up water on the drywall, and that's a good source of mold. So I'm doing everything I can to anticipate and reduce and minimize, possible damage to the house. On this particular setup, we don't have an auxiliary drain. Instead of having an auxiliary drain, we have an electrical shutoff. If, say for example, we develop a clog on our main drainage system here for the unit, we'll be able to, this unit will shut itself down once the drain pan fills up with water. And here we are looking at the kitchen. We have 2 dedicated appliance circuits. That is a code requirement. So that should be something all electricians that are listening to this should know and remember. And if you don't know, now you know. 2 appliance circuits. Garbage disposal has to be on its own circuit. We have an outlet here for the plug, and it's on the same circuit as the appliance circuit. And then here we got our hot and cold hot water lines. Code requires that they be insulated through and through. And one thing about me is, coming from a background of HVAC work, I don't like having seams that are open. So all of these pieces, I could have split them open and put them on, but these are unbroken. And the only thing I had to do is just kind of tape them. But that was something that I did here. But I'm very proud of what I did wiring wise. I mean, we got a couple of 3-way switches here. Had a couple of guys come that were curious as to how a 3-way switch works. So I did some drawings here trying to teach them. And then I told them, go ahead and watch some videos on YouTube. After you see me explain it a few times and you watch it on the video, it'll eventually start to make sense and stick. Over here, they put the shear wall in, and I have to readjust these plugs and get them to stand out like the way these other plugs are. Because if I don't, these 2 plugs are likely to get buried. The drywallers will miss them, because I did some of these in this previous job that I did in Hawthorne, and didn't work out too well for me. I ended up having to look at all of these photos, because we're taking a whole crap ton of photos to document where wires are in the event we have to trace things out in the future. And over here we have a couple of bypass ducts here. And what I mean by bypass duct, you see here the duct goes up and over and it comes into the room, but it's not hooked to the unit. Well, basically the theory is the room will get pressurized with this, and to relieve the pressure and to afford a better mixing of the air throughout the house, we're going to relieve a little bit of that by allowing the air that's being pushed into the room to get pushed up into this and empty into the hallway here close to the return. And theoretically, that's supposed to help minimize the buildup of stale air throughout the whole house. And we still have to create a fresh air mixing valve on our plenum. I mean, that plenum, it is huge, but this was something that when we did the math and designed this system, we decided to make the most of the headroom that's in the attic to get this thing fully optimized in terms of sound and airflow. So that's the reason why we got that. And here we are with the laundry room. We got our sub panel. Our main panel is either going to go between these two windows or between these two windows. We've been waiting for the electrical authority here to give us the green light, and we haven't gotten it yet. But notice all of the stapling. Code requirements for stapling of electrical wires is every 4 feet. But as you can see, I'm going almost at like every 12 inches or so. I just really think it makes the job look more professional, more complete, and it's less likely for you to have issues in terms of being able to trace things out. Yeah, and then here we got the bathtub valve going here, and then we have our drain here, and the offset distance from the center line to the edge of the tub. We have a 30-inch tub, so we need 14 inches clear to the center line of our drain, and so that would be adding another inch for drywall and tile over here. The distance here should be 45 inches, and I think that's what I measured it out to be. Another code requirement, y'all. Just giving you guys some of the rules of the game. And here we are here. We got our water lines here, and then we have the condensate line for the AC. And as you can see, I ended up wrapping it all the way up through the whole system and popping out the wall. The only place that you're gonna maybe have some issues with the condensate is gonna be here, but what we're gonna do is cut this and hopefully hook a flex line to the P-trap and get that water draining out here. Yeah, we got our fire sprinklers, and right now the water is on. Hot and cold is on. So everything's under pressure. Let me show you. Let me hit this real quick. So you can see it's under pressure now. So we got water under pressure. Or it should be under pressure. I know it was under pressure earlier today. I might have turned the valve off. We can rewind the video and see. But we got... What I'm very proud about, to be honest with you guys, is just the cleanliness of the job site. I was just so disappointed and dissatisfied with, end of the day, the framers really didn't want to take the time to really do a cleanup job. But I just really like a clean job site, because it's more of an expression of how professional, how serious you take your work, and the details. You're paying attention to small details as far as cleanliness. People pay attention to that. If the homeowners were to come today and look at this job site, they're going to see their house. They're not going to see clutter. They're not going to see sawdust. They're going to see their house taking shape, and it's so neat. They're going to be, wow, this is great. So I'll be back here in the morning. I moved a lot of stuff out onto the porch here because the inspector, he's already evaluated the porch, and we're going to end up getting the rest of this stuff out of here. This is my box, and this, and the air compressor. Everything else, credit that with the the framers. But they did, like I said, we're all working here together as a team, so I don't mean to call myself bad mouthing them. They, in my opinion, they did a very good job. Strapped everything, weren't too many delays, and here it is. We've been doing this job for, I think, 3 months now, 2-3 months. So we should be wrapping this thing up hopefully by the end of this month. Talk to you guys soon. Peace.